Okay, today we're 2 lessons away from the end of Unit 4, 8M4, Lesson 30, conversion between Celsius and Fahrenheit. And this is a little less about, actually Celsius and Fahrenheit, and talking more about just a cool application of the skills that you've learned in 8M4. This is super powerful. And let me see if I can hopefully I can really help you understand how powerful the math is that you've learned here in 8th grade. And we're gonna derive. So what we're gonna do today, and watch this. We're going to let's write it in green. Let's write it in green. We're going to not only talk about the conversion, but we're going to derive the formula to convert Fahrenheit to Celsius and Celsius to Fahrenheit. Now, for those of you who just to be extremely clear, Celsius and Fahrenheit are measures of temperature. Measures of temperature. And the Celsius scale, this is often used in science, and it's also used in most of the world. And most of the world. Fahrenheit is used in the US. So when we talk about temperature, what is a very common, a common temperature, things that we measure? We talk about our body temperature. When you go to the doctor, they measure your body temperature, and that in Fahrenheit is about 98.6. That's like the 98 degrees Fahrenheit. Now, if you talk about Celsius, it's about 37 degrees Celsius. If you talk about freezing water, where does water freeze? Freezing point for water. If it gets this cold outside, when will water freeze about? There's other factors, but for the most part, if there's not a bunch of salt in the water or other impurities, water will freeze at 32 degrees Fahrenheit and 0 degrees Celsius. And that's by definition. When they came up with the Celsius scale, they said, well, we're going to make it so that water freezes at 0. And then I don't know if you know what water boils at. Water. Water boils at 212 degrees Fahrenheit. And by definition, again, 100 degrees Celsius. So when they came up with Celsius and with Celsius scale, they looked at water and said, well, where does it freeze? And we're going to call that 0. And where does it boil? And we're going to call that 100. Fahrenheit, I'm not sure how they came up with their system and what measures there are. But you can do some research on the internet, and I'm sure you can figure it out in minutes. Okay, so we are going to derive the formula that converts Fahrenheit to Celsius and Celsius to Fahrenheit in this lesson. Okay. So what do we know? What is the key thing that we are told? And it's even underlined here in blue. And what do we know? We know that the relationship between the temperature measured in Celsius and temperature measured in Fahrenheit is linear. So we've learned a lot about linearity. But one thing that if two things are linear, and we'll convert over and we'll write this in orange, is that you can write things, if they're linear, then they can be expressed as y equals mx plus b. If two things have a linear relationship, y equals mx plus b will always be able to define their relationship. Now, y and x are the variables. These are variables, vars, and m and b are our constants. So what we're going to try to figure out is what this m is and what this b is. for our conversion. Okay. So now that's the first point. So we know that we can write the equation this way because I've told you that we have a linear relationship. So that's the first key point. The second key point is I've given you some information down here that will allow us to write this equation. Now let me get a little bit more, let me give you a little bit more hint on this thing. And so we're going to write this in a table, and this should really start to spark your memory and spark your curiosity and spark your or give you an aha moment. So let's see here. So the water, we have these 2 points that we know can be converted. If we use our conversion, we better, if we put a 0 in for Celsius, we better get out a 32 for Fahrenheit. So if we put a 0 in for Celsius, we better get a 32 for Fahrenheit. And if we put a 100 in for Celsius, it better give you 212 Fahrenheit. So remember, this is our freezing point for water, and this is our boiling point. Okay. Now, for those of you who maybe a little bit ahead of the game or really on it, you could say, wait a minute, Mr. Lipscomb, this is a table. This is a table or a T-chart. Table or T-chart. And if I have a table or a T-chart, I can convert that. I can do 2 things. I can convert it into a graph, and I can convert it into a algebraic equation. Algebraic equation. And again, that algebraic equation is going to look like this. Y equals mx plus b, because it's a linear relationship. All right, now I'm going to let you, let's just think about this for a second. And so we're going to do a couple things. We're going to do the algebra on this one, and we're going to find by finding our slope and our y-intercept, then we're going to graph it, and then we're going to turn around and we're going to write the equation the other way around, because you can always convert things in 2 directions. So I'll show you how to convert Celsius to Fahrenheit, and then we'll do Fahrenheit to Celsius, or I forget, one way or the other. Okay, so on this next slide, you got to hold this information in your brain. We're going to convert it over to the next slide. On this next slide, I'm going to bring our table with us, and I'm going to bring our formula that we're converting into with us. Okay. All right. So is this making sense? We are going to build our formula. So again, what did we say? We said our Celsius and our Fahrenheit, and this is X and Y. This is an X and Y chart, but we're going to use Celsius and Fahrenheit because we know what these X's and Y's represent in this case. So we're going to say 0 and 100 correspond to 32 and 212. And you know what? Maybe we'll just go ahead and build a quick graph off this, and I want to show you, what we're going to do here. If this point is 0, 32, and then we're going to build, this is 0, 32. Why can't I write this? 0, 32 right here. And this is Fahrenheit, and this is Celsius. And over here, we're going to have like 100, 212. We're going to have and then we'll have a straight line here. And we're going to write the equation of that line. Okay. So what is our slope? So let's find, so we're going to try and write this as y equals mx plus b, or more accurately, when we use these letters for our x and our y, we're going to say F, Fahrenheit, equals M times C plus B. And we're looking for this M and this B here. So let's switch colors as we go through our math. So we need to find, remember, when we have 2 points, we first, we find our slope. And 2, we find our y-intercept. For some of you may be noticing actually that you actually have a y-intercept here, but let's do this. But let's just do this the traditional way, because you could do this the other way. Because we have this y-intercept, we actually could just go. We could find the y-intercept first and then go to the slope. But let's do it the other way, just because it's a little harder and it will always work, because one of your points isn't always a y-intercept. Okay, so remember our formula. Our slope is equal to the y's, the difference in y's over the difference in x's. Right? This is our rise over our run. Our rise is the difference in y's, and our run is our difference in, this is our run, and this is our rise. So if we subtract our y's, we get 212 minus 32. And we subtract our x's, we get 100 minus 0. So here we have 180 over 100. This is our slope. That simplifies if we divide by 10. I'm going to divide both sides by 10. 18 over 10. Now if we divide by 2, we get 9 over 5. And so that's our slope. Now we can plug in to either point, and I'm going to use this point to plug in because it's so easy to use, so easy to see. And so let's take our F equals M, 9/5, because now we know our M. Right? F equals MC plus B. We know our M plus B. F equals 9/5 C plus B. And now we're going to use this point, and we're going to plug it in, and then we're going to see if we can find out our B. So our F is 32 equals 9/5 times 0. C is 0. Plus B. Oh, this is working out nice. 32 equals 0 plus B. 32 equals B. So our slope is 9/5. Our B is 32. So our final answer here is F equals 9/5 times C plus 32. And this may be a formula that you've already memorized in science class. That's very cool. F equals 9/5 C plus 32. So let's now go ahead and graph that. Now we're going to graph this. Let's pull this over to the next slide for graphing. And then we're going to convert it the other way around so that we have C in terms of F. This is F in terms of C. Right? This is a great formula right here if you know your Celsius and want to convert it to F, but it doesn't convert F directly into Celsius without doing a little bit trickier math. Okay, so let's do our graph. And we'll kind of make it a little bit longer in these two directions. Okay. All right. So here, this is our X. So our Celsius goes here, our Fahrenheit goes here, and our Celsius will go, we won't make these on the same 10, 20, 30, 40, 50. We won't use the same scale, 60, 70, 80, 90, 100. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. That's 100. Okay, in Fahrenheit, we're going to do it more like we'll make 100 every 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we'll go 100 for 8. 1, 2, 3, 4, 5, 6, 7, 8. 200. So 50 is 4. So this is 50. 50. This is 150. And so every that's 12.5. So yeah, see, so every 1, 2, 3. So that's like 12.5. Or these are 25. 2 is 25. So that's 225 at the top. So we need to graph again. So we got to plot our 2 points. Let's just plot our 2 points here. This is going to be the easiest way to do it. C and F. We got 0 and 100. And here we got 100 and 212. So 0, comma, sorry, that's not right. 0, 32. So 0, comma, 30, 32. See, this is right about, that's 37. 32 is going to be right about here. Let's graph this in a different color. So that's 0, comma, 32. And then we have 100, comma, 212, which is right about here. There we go. So let's see, we know there's another point on here, and I just know this because I go to my doctor and sometimes they'll read it this way, but they'll sometimes give you your because doctors in America both live in America where we use Fahrenheit, but they also live in kind of the scientific world where we use Celsius. So sometimes they'll read my temperature in Celsius, and the Fahrenheit version of temperature is 98.6. So let's make sure that point exists on this line because it's better. So let's see, 37 would be right about here. And then if we go right up to here, or right here. So that looks about right, because if we come down here again to 37, that's just below 100. And so here's our point, 37, 98.6. And so we have developed the graph. We have graphed, C versus F, and we've gotten the equation that connects how we convert any temperature in Celsius to Fahrenheit. So now if I told you in Celsius, I have a temperature of 50, what is the temperature in Fahrenheit? I would just go, well, 50 in Celsius. I go, well, 9/5 of 50 plus 32. And so cancel, 10. I get 90 plus 32 equals 122. 122. So let's see, 50, comma, right here. Right there, because this is, 125. So that's right. So I could say also if Celsius is, 0 to 32, and I can ask all kinds of questions. I could say, well, what if Celsius is, 80? I'd go, well, 9/5 of 80. Well, that's 5, that's 16. 9 times 16 is 144 plus 32 plus 32 equals 176. So let's see, 80, that's right here. And then I go across to here, right? And this is 175, so that's about right on. It's right on. Okay, graphs are never exactly perfect because you get a little bit of error when you start drawing these dashed lines and you don't have perfect tools, but it's very close, and the graphs are great for estimation. So now let's take this formula one more step, and let's rewrite this formula in terms of and convert Fahrenheit to Celsius, because this helps you convert Celsius to Fahrenheit very easily. So that's the last part of the lesson that I'm going to show you. So if we know that this is the conversion from Celsius to Fahrenheit, all we need to do to convert the other way is solve this equation for C. And that goes back to some algebra that you learned probably in 7th grade. And we have to now isolate and solve for C. So how do we do that? Well, let's get our constant over on the other side. So let's do it like this. Let's go subtract 32. Subtract 32, and we get F minus 32 equals 9/5 C. And now we can multiply both sides by 5/9. And we get this cancels. And we get C equals, and I'll write it like this. I'll put it on the other side. 5/9 of F minus 32. And this is the way it's typically written, like this. This is not in graphing format because you don't have the constant by itself. You have this parameter. You have this multiplier that multiplies by this whole piece. So if you wanted to put this in graphing format, you'd have to distribute, and you'd say, well, Celsius equals 5/9 F minus 32 times 5 is 160 over 9, which is equal to 5/9 Fahrenheit minus, well, let's see, 160 divided by, I'm on my calculator right now, divided by 9 is 17 minus 17 and 53 and 7/9. So C equals 5/9 Fahrenheit minus 17 and 7/9, but it's usually written like this because it makes the conversion easy. So let's say we now want to convert Fahrenheit into Celsius, and we know that let's just make sure 32. Let's make sure 32 works. That should give us what? It should give us 0. So now if we say, well, 5/9 of 32 minus 32, well, that's 5/9 times 0. Well, that equals 0. So that works out. So now the other one, Fahrenheit, we should be able to convert, 212. That should convert to 100, but let's make sure that it does. C equals 5/9 of 212 minus 32. Does that, the question mark is does that equal 100? Well, 5/9 of 180. Cancel the 5 and cancel the 9 and the 180, and you get 20. So that equals 100. So check. Yes. Happy cat. So hopefully, hopefully this was an informative lesson. This is just an application of knowledge of linear equations. Let's go back to where we started. We looked at this question of a relationship between temperature measured in Celsius and Fahrenheit is linear, and knowing that it was linear, and knowing just 2 points that fit, or 2 ordered pairs that fit in a table, knowing that piece and that piece was all we needed to know to derive the formula for converting Celsius into Fahrenheit and Fahrenheit into Celsius. And again, those equations are right here, and right here. So one more lesson to go. And in this last lesson, 8 and 4, lesson 31, you are going to learn about how you can find Pythagorean triples. So we're going to go use this powerful tool that we have learned in linear equations, simultaneous equations, and we're going to use that formula actually. And this the ancient Babylonians, Egyptians, I'll figure it out before the next lesson, but they knew how to find Pythagorean triples. In other words, numbers that would fit on the sides of right triangles that had that didn't need any irrational expressions. So 3, 4, 5. They knew how to find find the 3, 4, 5 triangle, could find the 5, 12, 13 triangle, the 7, 24, 25 triangle. They knew how to figure out those triangles that have those perfect numbers that don't need to have irrationals on any side of the right triangle to be in and it is a right triangle. I know that's way wordy. I botched my explanation, but we'll do that next. Over and out. And after next lesson, we'll move on to 8 and 5.